So it's the end of the day panel. So, we want to use this as an opportunity to touch on topics that might have not a lot of chance to talk about. So I'm going to start with a couple of kind of general questions. And then after that, I would like to get some questions from the audience as well, okay? So maybe kind of following up with the last question. So this coding agents, right? A lot of these coding agents are happening, things like Google Jules, OpenAI Codex, right? What do you think today is the key challenges that practitioners, and companies having in the next 3 years? Okay, so any thoughts on that? We're gonna have we don't have to go for everybody. So if anybody wants to say, put your hand up. I'll bring you the mic.
So I think it's actually a follow-up on what we were discussing for the last talk. One of the key challenges I see with the models these days is the ability to go over them, review them at scale. So they are generating lots and lots of code, and humans are falling back in the sense that we cannot keep up with reviewing these big chunks of code. And in many cases, developers don't have enough experience to even review these critically. So that's one of the challenges I think we are facing today.
So I think related to that, I think right now every tool that we have in the pipeline is there to help us write code, but we won't be writing code that much anymore. So we need new IDE, new tools, or at least tools that allow us to use these LLMs better. Maybe these tools are used internally by the LLMs, but this whole pipeline of tooling needs to change. But we don't really know how yet.
So another thing I guess is that we need new methodologies and processes that have the LLM aspect ingrained in them. And when companies or teams are developing the project, maybe they have a special phase for, I don't know, discussing what LLM is doing, or I don't know, break some previous steps into more detailed ones, like requirements to some more. So when we're going from waterfall to agile, we basically were trying to move a bit faster to the code part, to writing code ourselves instead of requirement, but maybe it's better to first focus on what requirement is in terms of natural language among the developers themselves, describing it for the LLM. So this is something that researchers should pay attention to, and then everybody else should also integrate these into their pipelines.
Yeah, I guess I will touch on the point of asset management, where right now most of the asset management, as previous talks has talked about, focusing on code and code alone, and it's more of these agents are used in production for code generation. There are definitely more things to track. Firstly, is which code is generated by which agent, at which version, using which model, and what are the inference parameters. And then secondly is to drive the generation of this piece of asset, the code, how the asset went in there, like what kind of project context were used, what kind of dialogue were used. All of these things are not considered in the traditional version management system or asset tracking system, and those things probably need to be improved a lot to catch up with the mechanism right now.
So, okay. All the way back there, man. Okay, I have to run and walk to you.
So, one thing that I'm noticing is in the beginning of the LLMs being used for code completion. Earlier, we had the concern, okay, there are a lot of crappy code out there on GitHub and all these other repositories. So if you train on these crappy code, you will get crappy code as well, anti-patterns, issues, bugs, all these things. But I think more and more, it's an issue for a certain level, but most of the time it's following best practices and adhering to all the guidelines if we provide the guidelines. So it's not, the problem is becoming a different problem now. I think the most important thing now is how can we, like, are these best practices still relevant if the code is being read by other agents, not by humans? For example, size of a class, size of a method, or how we architect software. It's mostly was designed for cognitive load of humans and thinking style of humans. Is it relevant if code is consumed by foundational models and generated by foundational models? So do we need to think about how to design libraries, how to design API documentation, how to design interfaces so that it can be easily consumed or effectively consumed by foundational model-based agents going ahead? Yeah.
But if it's no longer human readable, how do you review it? Or do we just assume that it's correct at some point?
So for certain applications we need to have like formal verification from the code that make sure it's working or things like that. But most of the time we don't need to look at the code to make sure it's correct. We observe the outputs, we have tests and things like that.
Well, so, today we don't look at the compiler output, right? We trust it. So if code is the level of binary, I think we're going to get to that level. Maybe not next week, but that's where we're going, right? And I think the other thing, the main thing is there's almost like two software engineers that are happening, right? One is how to make the code easier and convenient for agents to live in. And they're going to be doing that. And actually, that's the place where I think still there's a lot of work that can be done by humans to help agents. And then there's a whole other area, which is software engineering, where your team has a lot of agents in it, right? So now, a lot of soft-feeling words here. So, but right now, what I want to ask is, so I'm a young person, a junior developer. What should I do? Can any one of you give some advice? So there's a lot of junior people here, and they want to what do I need to excel in? What do I need to focus on in the next 1 or 2 years, for me to actually excel in this field? Any thoughts on that? Okay, he has the answer.
So I think one of the most important skills that is also now or previously often overlooked is for people to have the will to push something from end to end. So I think that's something that LLM may lack a bit right now and needs someone to be on top of everything from beginning to end. So I think one of the most important software skills that new generation needs is to just own, maybe I start from small projects, but own projects and start doing it with the LLM and own it to the end, see how far you can go, how you can implement it, how you can deploy it, how you can do everything yourself. As you said, there are many companies that are already growing and they are only 1 or 2% company using AI. So I think this is one of the skills that will be very helpful in the future as well.
So actually the advice, and I'm not sure how useful it is for people here, but the advice I give to undergrad students who ask that question is I advise them to do grad studies right now. Because now is actually the time to do master or PhD, because it gives you some time to play around with these tools and to really dive into technology without needing to deliver immediately, because it's a bit of a mess on the job market, maybe more in some places than others, but now is actually a great time to take 2 or 3 or 4 years to really dive into this new technology, right? So.
I guess a lot of junior people that I've met, especially in the job market, they would have a behavior that they can write code with an AI assistant. They can, like, for example, if you throw them a lead code question or the typical interview question, they can write it with the assistants. But if the code has some bug, then they got stuck there. They weren't sure how to debug their initial request to those assistants to fix the issue. They end up in a loop of just, hoping magical things will happen by throwing the error message back in. Of course, that's the principle of vibe coding, but lots of time it doesn't work if the model cannot solve in the first run as well. So how to best utilize the assistants, how knowing when to take over, what other options you have when dealing with software development beyond model capabilities. I guess those are what junior people would have to deal with in this current situation.
Yeah, and to add on to that, I believe that students need to find the right balance between learning the fundamentals, not ignoring them, and not over-relying on the models to do everything for them, because if you are going from coding to reviewing and debugging, you need to know your fundamentals. So writing exactly the fine balance between the fundamentals and how to debug them, how to evaluate them as we go to more reviewing in this era.
Yeah, I think I like this. The idea is like, make sure you try them out, right? So make sure you actually play with these agents, see their capability, see their limitations, right? And as well, if you're a graduate student, I think you owe it to yourself and to your research to say, let's see if everything I'm doing, if that could be done with an LLM today, right? That's a question that you really need to be able to answer to yourself, okay? And then the other thing is you need to be able as well to figure, okay, when things go wrong, how you can get better. And then as Cor-Paul said, I have the same advice. My thought is stay out of industry for the next year or two. It's gonna be a bloodbath, say in academia, and then you could jump in, okay? That's my view, but with more of an academic here. Okay, so I think software development has always had this, 10x developer, right? So 10x developer is a developer that is 10 times better than the average developer, okay? And my hypothesis is actually with LLMs of that, we're gonna have the 100x, the 1000x developer. Now, the 10x developer that we knew in the past was a super hacker, he's a VI wizard, right? He knows how to use the compiler, but that's totally changing, right? What is the 100x or the 1000x developer? So, today, what kind of skill sets you think are so essential to be in the 1000x developer?
I would say probably to go from 10x, which is yourself being an excellent coder, to 100 or 1000x means that you have to switch the mindset to a delegator or coordinator among the army of AIs that you know how to break down tasks to, and you know how to coordinate them to solve the problem, thus maximizing the efficiency. And that means that sometimes senior developers know what they need to achieve, but they cannot put it to words. Then you cannot really utilize the tools best to delegate tasks. So I guess task delegation and breakdown becomes what differentiate 10x to 100x developers.
So I think instead of a coder, you become more of a reviewer. Because I saw this LinkedIn post from somebody who said, instead of waking up and deciding on which issue report I'm going to work today, the day before he just programs 100 agents to work on one open issue report, and then in the morning he reviews the ones that are the most likely to be correct, and then go from there, right? So you won't be writing tons of code anymore. You just generate a lot of code and you pick the best version from it.
So, in my opinion, I think we have to look at this in the short term and in the long term. Like in short term, engineers need to learn how to efficiently use these tools. So all these prompts and all these agents have their own quirks. They are not perfect yet. So if you are reading about this, trying these things out and how to efficiently maneuver these tools, you will be more productive. But in the long term, they are going to iron out all these quirks, and it's just a matter of how to express your requirements to these tools, and they will effectively do your job. At that point, your skills become how to communicate your requirements, how to communicate your outputs and things like that. That's in the long term. But until then, it's about cleaning up the shortcomings of these models, or learning about how these different models behave, learning about these internals, how models work, these things, so they can you can work around the current shortcomings. But this is going to be a short-term thing. Eventually, it's going to get better. Then you have to work at a different level. So that's what I'm thinking.
So I think we should treat these technologies as we treat any other disruptive technology so far. I do remember when search engines came out, there was this phrase of the skill of Googling. Like people who could Google would be better at their own work. For LLMs, I would say that learn and master the art of prompting, actually. Develop a feeling for different models, different versions of the models. So it needs you to practice with them, play with them, and learn how to talk to them, how to convey your request, how to structure it, what kind of context you need to provide, even the order of the information you are providing. It can differ per model, per tooling, etc. So as long as you play with them and you learn them, you can master them. And for example, you can also even develop your own prompt library, have like a versioning over them, and I would guess that can come handy. Yeah.
So I think it's a combination of many soft skills. So previously, you needed to know a lot of details about specific things or technologies, but I think the more we progress, the more it's important for you to know how to think, know critical thinking, problem solving, clear communication, research. I think these are the skills that in near future or even now sets you apart from people that don't know these skills.
So, I mean, for me, one skill is as well the ability to mentor. So I think of these AI agents as well a teammate, and you want to be able to mentor them and train them and make them better. So I think today, one of the problems a lot of people do is they're still treating these LLMs as Google in a way. Just ask them simple questions. They don't realize they are lifelong, and the more you teach it, the more you spend time working with it, the more actually you learn. So what I find today is even when I use ChatGPT to do stuff, and for example, help me write an email, then I take it, I edit it a little bit, and then I actually give it back to it and says, hey, just so you know, this is actually my final copy. Learn from my copy, remember, tell me what you learned, and then tell to remember these skills. So next time I ask you, you need to do these, right? So the mentorship, so I think I agree on the part on the orchestration and management and kind of, reorganizing work and pushing work, but as well realizing that the more time you build to mentor them, the more actually you'll get back out of them as well. Okay, let me move on to this thing about, so there's a lot of benchmarks, right? Whether it's SweetBench or human eval, and then there's the reality of the world, right? So today, you pick an LLM, it performs very well on benchmarks, but then when you start using in your case, it doesn't perform as well. So I don't know if any people have any best practices that you have found, to help you actually pick the right large language model for your task. And whether it's only one large language model is enough, or you think application could have multiple large language models as well. Okay. Okay, good.
So for me, I think there's some use with published benchmarks. We can get a sense of how capable the model are, but it always depends on the task, what you want to do. So you need to have your own benchmarks if it is a special task that you want in a certain domain, and even if it is for personal use, you may have your own benchmarks, similar to the popular Pelican benchmark. Like this developer has this benchmark for all the release models. It's asking, can you generate an Pelican on a bicycle in the SVG format? Some things like that to quickly check if the model is capable for tasks that you want it to perform. So you may have your own benchmark like this that just to capture the requirements you have.
So I think Footscom from Polytechnique Montreal spoke about this, where currently the benchmarks, they basically give us one score, right? They give us one number. So we don't know whether it's good at a certain part of the benchmark, or it would be nicer if we have a breakdown of the benchmarks where we know we have categories or certain tasks where we actually know that it's really good at generating bug reports, but it cannot do this and this task. That's something that I feel is really helpful to know, because then you can actually better select a benchmark that fits what you're trying to do.
So today I talked about benchmarks, and I think I had a few suggestions about like data contamination, avoiding those, and like using human eval, etc., just as a smoke test because they are saturated. One aspect that I didn't explicitly pointed out is like the freshness of the data, which is also being ignored so far. And I would say that if you're a company and you want to test your models and your toolings, make sure that you keep your data fresh to avoid data drift, concept drift, and you are able to catch those at least. And that can be a rolling version of like, as the new data comes in, you put it into a dataset framework and you create a new set of data so that the results that you get aren't like overdated.
Thanks. I agree with the points, other points, and maybe elaborate a bit more on the fact that for special tasks you may need special benchmarks. But again, to have your benchmark, you also have to exactly know what you want. So I think that's also very important to really shape up the requirement that you have for the model first and realize, oh, I exactly want these skills to be this good. Maybe those skills are okay if I'm not that good. So first, shaping the requirement for yourself is actually also very important. I think they should focus.
You can say if you don't want, it's okay.
Okay. Well, I'm actually agreeing with the previous panelists that understanding your specific task characteristics becomes essential in even constructing your own benchmark, because there are some things you want to test for these models. For example, if your task requires a very long context, you might want to focus on that. But certain tasks require the model be really good at following a very specific structured output. Then models that can comprehend the context but cannot do a really strict format generation might not be the one for you. So understanding the specific requirements of the downstream task becomes very important.
So I have a lot of questions, okay? But I think I would like to get some questions from the audience if anybody has any questions. Otherwise, I'll continue. Okay, good. Thank you.
One of my questions in general was answered a little bit by you saying that code is going to be the new assembly code, is about human creativity. Until now, we're training models based on code that humans and literature and text that humans have written and opinions. But as you said, like junior developers, I'm well, like a senior citizen here, but like junior developers don't apply the same debugging skills that I learned, through toiling through like the junior ranks. Are we in danger of getting like stuck in terms of creativity because the models will keep doing the same thing and training themselves and reinforcing the same state of affairs? How can we inject a bit of creativity into it? And I guess counter argument is like, if code is not that important anymore, it's more like bytecode, is the creativity is on the concept and on the intent rather than on how you implement it. So I might be answering my own questions here, but I would be interested in your opinion in general, not just for code, but for LLMs.
So I think at some point you can view coding as like playing chess. Like I'm not sure how important creativity is at some point, because for chess a computer can just do all the moves and it becomes a computational problem. So for coding this is not as straightforward, but I still think you can sort of limit the search space, and then it's just a matter of trying different things. And if the developer doesn't have to do that, it's automated, then the model can improve itself or can improve its solutions by just trying things and running things and going from there. I think that's where it's heading at some point.
So I do think that at least in the short to mid-term, it wouldn't be like the creativity parts will live on both the design and the code level, especially when it comes to algorithmic innovation. But a lot of engineering tasks are not algorithmic innovation. They are repetition of existing patterns. So those things definitely could be replaced. And then a lot of innovation could come in at the design level or at the algorithm level that human can instruct, or human can co-create with the code. I guess it gives people the freedom of deciding to stay at a higher level or go into the lower level, while eliminating the need to be trapped in certain repetitive work. So I think that's how people might need to balance the creativity part and the repetition part of engineering.
So today, one of the ways people using coding agents is they give the same task to 10 coding agents or 5 coding agents, okay? And then it's vague enough that the randomness of these agents actually creates some type of creativity or some type of explorations where people say, I really love what you did on the front end was Agent 1 solution, and Agent 4 solution, I really like the back end, okay? So we're seeing different ways of creativity as well being applied. That's one. Second, the speed of the feedback loop is so fast. A lot of times we as humans, we don't even know what's possible, what we don't want, what we want until we see it. And now when it can be done in seconds. So the human's still part of the loop and can still drive the creativity. But now kind of the sky's the limit, because you can literally say, take this, implement it 20 different ways, and I want it in half an hour. And then, okay, yeah, I was totally wrong. Actually, I don't want this at all. This is a dumb idea. So I think if longer we can figure out how to keep the human in the right place and really take the power of the human and take the power of the agents, I think we can achieve something in the middle. And as well as Dai said, I think there's a lot of things that are just monkey stuff too. Any other? Okay. Oh.
So, yes, as you said, there's in some areas, innovation, I feel like it'll stagnate. For example, now people won't care much about syntax or some tasks that you can get done using a foundation model easily. But at the same time, people will focus on higher level things like design and architecture of software systems, not worrying about trivial details about the language syntax and things like that. But at the same time, sure, in that case, programming language, like creativity in designing programming languages, is it going to stop? I don't think so. Programming language enthusiasts will keep innovating new syntax. Could be FM-friendly languages or more design-friendly languages, things like that. So in that part, there's going to, like, I think innovation will happen in this space even then. But as you said, there's going to be some cleaning up to do even in the medium term. There's going to be a lot of edge cases not caught by foundation models, debugging skills. We will still have to debug machine-generated code, solve production issues, things like that, until we have fully capable agents that could resolve production issues, or that agents that can resolve maintenance tasks. In the short term, we will have to keep fixing production issues, so we will need to have skills for that. Yeah.
I have another question here. Okay.
Talking about the evolution of a POC or prototype to a robust and reliable system deployed in production. What are things you think we have to consider? One example for the security aspect is the prompt injection. So we have to include some guardrails, safe guardrails. But what else? And what are other aspects as well that you think are very important when we deploy an AI application or agents?
So one of the aspects you need to care about is the trade-off between the cost and the performance. The choice of the models that you have, like going from a POC, in the POC you can use a very fancy model, but in reality you may want to go with a small model which has less latency, uses less cost. So these are aspects that you can think about. Privacy would be another aspect, because when you have something just to play with, you don't think about it that much, but in production you need to care about those aspects. So then it leads you down the path of, should I use open-weight, open source models that I can host them locally, or do I need to use like services like online services, etc. That then you need to share the data. So user privacy, data privacy, these are like some aspects that I think you need to pay attention to. Yeah.
So I think, as I also touched upon in my presentation, one area would be the trade-off between the agency and the determinism. So if you want a really fast MVP or like tool to play with, you can just give LLM as much freedom as you can and ask it to do basically everything it can. And you have a product you can play with very fast, but it may break in many places, and gradually take the control from the LLM and implement them in small functions.
I think the most important aspect we need to look into is, should we actually use a foundation model for this task? There are a lot of cases that we can get away with some algorithm or get away with some traditional machine learning method, but because if you think about it, it's still doing next token prediction. So is it suitable? Is a foundation model is the most suitable thing for this particular task? And even with the reasoning models, if you think about it, what they're doing is generating reasoning traces. So we have to think about whether it's actually reasoning or pretending to be reasoning. So should we use a reasoning model for this task? Because the most common anti-pattern or most common thing I noticed is instead of, people prompt the model asking, can you give me an answer for X, instead of saying, can you generate me the Python code that can give me the answer for X? So LLMs are good at that second type of tasks, like it can generate Python code or some other code to solve some problem, instead of trying to find an answer for that thing. But since they tend to hallucinate. They, most of the time, instead of generating Python code and answering, it'll try to give an answer. So we have to be very careful what type of tasks we are using the foundation models for.
I think when we're building traditional software, people are already very used to the concept that you need to do instrumentation, you need to put in logging, you need to put in monitoring in place before you went live, so that you can monitor post-production and then figure out if everything is okay, right? But that becomes not as straightforward when it comes to these kind of systems, especially when you're building a demo. You're just chain together several prompts, or you're just chain together a workflow, or pull two agents up and let them talk to each other. But are you monitoring their resource consumption? Are you monitoring what kind of external information they are pulling in, and all those things? And also, are you monitoring whether, especially in multi-agent system, they sometimes get stuck in an endless chat loop, and then they just burn your API budget in like 1 hour that you're not even aware of. So all these new observability, monitoring, and logging challenges in the area of large model applications is something that really needs to keep up with the speed of delivering this kind of system.
So I'm going to give a plug for, so Gopi's not around, but I'm going to give a plug. So he has a paper that's called From Cool Demos to Production Ready FMware, right, where he kind of goes through very detailed from the experiences him and his team about how do you take it from a cool demo to a production. And there's a lot of things that a lot of people talked about. And the biggest challenge today is that it's very easy to show a very cool demo, and then business leaders say, well, if it took you this long to actually have a cool demo, all you need is 2 weeks and we can ship, right? And what people are realizing, it's considerably harder to ship this type of software and make it robust compared to the classical software. So this is, I think, one of the biggest challenges, whether it's cost, monitoring, reliability, and so on. So there's many things, and I think right now the reality is we're kind of building this software using, punch cards. Like, it's just very basic support and very basic technologies available for the people that are building that type of software. And I think there's a lot of work that needs to be done in that space to move it from kind of like, okay, you're lucky that you got it out versus an engineering process. Okay, yeah. Any other questions? Okay, yeah, 1 second.
I actually have 2 questions. The first one is related to, I don't remember who it was, that talked about multiple PRs from agents that come in and them being rejected. I was just wondering, don't the agents then learn over time that they are being rejected and then do smaller ones, for example? And related to that, yeah, does that lead us to coming up with guidelines for having PRs? So that's the first question. The second one, we are talking about a lot of code and how it generates the output once you give the prompts. But what about design and architecture? Are we going to miss learning the basics of design and architecture by continuing on this line?
Well, the first question was for me, man.
No, I thought it was for me. Yeah. So I think it's not. So I think it wasn't my work, but I think what he did was basically the afternoon before he picked which issue reports he wanted to work on, and then sent like 10 agents for every issue report to generate the solution. So you still pick the ones that you work on. It's just you're not actually working on them like the whole day by writing code, right? But I guess even if you would let agents look for which reports they want to solve, they do the easy ones very fast, and you get those out of the way. In a way, that's what a developer does too, right? Like, you can tell them to prioritize certain things, but I'm not sure it's necessarily a bad thing that they do the easy ones first, because at some point, all the easy ones are gone, and they still need to do the harder ones.
So I think that Right now, agents get errors, but we haven't got to the stage where agents learn and loop back, right? So, but it won't be long before we're gonna get to that, right? Today, what ends up happening, a lot of the people use this agentic coding, they call it, autonomous coding agents, is when they fail, then the human actually gives them kind of like mentorship and says, okay, I don't like this. This is why I don't like it. It's too long. Make sure next time you write this type of documentation. And now today we're almost creating a new type of artifact, which is this mentorship scripts. So these are called like this Claude.md files that are scattered throughout the code base. And all they are is this advice that the people that are working on the code are giving to the agent. So next time the agent is working inside this piece of code, they read that and they actually have more specialized mentorship. So, but eventually it's very obvious that the next step, the agents will actually say, okay, I did this, the boss didn't like it, the boss being the human, what he didn't like, okay, from there I should actually derive some lessons for myself. Maybe check with the human, say if they're happy with them, or I'll just learn for myself and kind of collecting. And over the years, that agent will become better and better over time. Yeah, okay. Just a second.
I don't know, it's just my thought process about the whole situation, is that we are mentioning that agents will become better by you supporting them, to mentoring them to become better. Then we mentioned that these agents reduce the need for the juniors, and seniors work with them, and also juniors need to, instead of experiencing the coding thing, learn how to use agents. And then there is a broken chain of these juniors that want to mentoring these models. They don't have the experience on the code. And then who needs to mentor these agents to become better? It's then either it's like that, or juniors need to learn these tools on top of learning the codes and getting the experience of becoming seniors on their extra times themselves. So what is the opinion on this matter?
So this is a hard one. I'm going to get the panelists to do that one.
So there's the short and medium term solutions, and then there's the long term ones. So yeah, you're absolutely correct that we have to have some knowledge about the code itself, architecture itself, and about using these tools to see how they are working to make them better. So it's a very difficult process. Because right now the models are not continually improving themselves. So all these methods we are talking about, having these files outside of the agents to store these rules over time, guiding them, providing instructions. These are just workarounds because we don't have a better way of encoding this in the model weights itself. So we have all these like changing rules, stored them in vector databases, or just markdown files in the repository. Teaching them what are the best practices to use in this code repository. Once you do an issue resolution, update this rule file to do learn about that thing in the future. All these things are workarounds that we have to do because the models are not really encoding these things in their weights. It's just workarounds around that. So, but in a future where we will have auto-updating models, so weights getting updated over time, yes, they can learn about these things. Until that time, we will have to have workarounds like that. But as you said, yes, of course, at the same time, there are going to be a problem when juniors don't have experience about these code bases, about the architecture, about debugging, about looking at traces and trying to solve problems. So there are going to be a time, these things matter, but the senior developers are already retired. There's no one with this experience. I guess the bet that these companies or tool builders are having is like, oh, the models will be better at that time. They don't want to get this information or path correction from junior developers. So maybe that's what they're aiming for. But if the models are not improved to that level, absolutely it's going to be a problem, in my opinion.
So I think right now when a junior developer joins a project, you're not let them work on the whole project, right? You let them first work on a small part that's maybe a bit more easy to understand. And I think that's not going to change. Like when somebody joins a project, based on their experience, they get to work on very difficult parts of the project or easier parts. So I don't think that's going to change much, to be honest. It's just the actual amount of code that they write themselves, that's going to change. And what I could see is that they could first mentor the AI assistants that work on the easier tasks, and then they grow into the project as well. So I think that the process overall is not that different from what's happening right now.
I guess one possible scenario that could happen in the future would be, like, as a reaction of the whole industry, would be, for example, to hire junior mentor developers instead of junior, Java developers, for example. So I guess probably over time the skills will change, and we will understand how to cope with this as a society, and prepare young developers for those specific tasks, and then hopefully that could happen.
The whole process of software engineer students become like being a good prompt engineers. That's it. It's like
Well, no. So
design systems or something, databases, who cares? You just tell the models to do this SQL code.
But to review, you need to understand what's going on, right? So I think thank you. So I think that's definitely an important skill set for new graduates, right? They need to know how to do prompt engineering, but they also still need to know how beyond that things work, because otherwise, if you can only do prompt engineering, and I see that with students in my course, then they do prompt engineering and they just copy paste, and then might be garbage, but they don't know because they don't understand what's going on, right? So you still need that basic knowledge. Just the way that you use that knowledge is going to be different.
It's not fun if you are not arguing in a panel, so I'm going to have a contradictory opinion about that. So you said not much is going to change. Even now, junior people are going to work on a small part of the project. Over time, still they are going to work on a less critical part and learn on the job or something like that. But fundamentally, the things that they have to do is different. Like earlier, people had to write code themselves, had to worry about syntax errors, have to learn through experience, learn through all these hours spending trying to debug errors in systems. People will not have to experience this anymore. So you will not have these hard experiences as junior developers. Earlier, you had to go through this, but now you won't have that experience. So I think the question was how you become a senior engineer if you don't get these experience as a junior engineer. So I think there's a difference how it was done in the past and how it was done in the present and in the future. So I think the point is it's going to change what the junior engineers experience when they're starting on the job is going to be fundamentally different. What they're exposed to is going to be fundamentally different. So how and when they become senior engineers is also going to change because of this.
But why is it fundamentally different? Like, sure, you're not wasting time on fixing syntax errors, right? But in the end, the process of being onboarded on a project, I don't think is going to be very different. Like, from a point of view where you work on simpler tasks first, and then proceed to harder tasks, right? Just, yeah, you're not fixing syntax errors or whatever, but still you have to look at whatever is being generated. You're reviewing more than generating code. But I think fundamentally, that's not going to be very different, right? You just have a tool who does the dumb work for you.
So I think I agree on you're going to go from easier to harder. Okay, so there's no doubt on that. But let me put it this way: today, most junior developers interact a lot more with the agents than other humans. Okay, today, if you're a junior developer, if somebody wants you to if you want somebody to write you a reference letter, ChatGPT could write you a better reference letter than the rest of your team. Okay, which means the dynamics in a software project are totally changing now, right? You know, you actually feel grateful more to the AI than to the other humans. Okay, so it totally changes the dynamics. So I think the dynamics will change. On that part about growth and how you do stuff, I agree with this, but I think other things will change. And I think in the same way we talk about we need to mentor these agents, actually the agents should be designed to turn around and say, you know what, Cor-Paul, I really think you're very weak on on concurrency. Like, dude, here's 2 books, or here's a little, primer on concurrency. Can you just read this? Because every time you ask me these things, that make no sense, okay? But right now, the problem is the large language models are built almost like a drug dealer, right? You want this, you want this, you want this. It's not actually thinking as well about your growth as a human and as a developer. So that's another kind of more social responsibility of the large language model providers. And we saw some of that when when OpenAI removed GPT-4o, right? A lot of people were actually kind of dependent on it, for social kind of skills and stuff like that, right? So we're getting in a very interesting field where actually something is not because it's good, it's just because we have actually become more dependent on it. So there's a lot of dynamics that will change as well. Okay, I'm gonna do this one and then this one, and that's it.
I mean, on the last one, something that I've seen personally is the themes around institutional memory, institutional culture, and now that you're saying the SDLC is changing completely, I will dare to say that even the management structure has been changing a lot in the past few years. A lot of people get fired, people come in, you lose institutional knowledge, your culture becomes messed up. You lose the senior developers, you have a bunch of junior developers have no clue what's happening. So I think there are solutions here, like when you say you do intent-driven development rather than actual development. If you develop more knowledge base, you won't depend so much on that one person that built it and he's the only one who knows how this tool works, right? You will need to replace him. So I think in the future, probably, you won't depend so much on people, you will depend more on institutional knowledge bases, and those tools might even replace your management, like in the sense that now a manager will decide what is the priority, what is the next step. In the future, probably an LLM or whatever, a model might say, look, that's where we're going next based on what I see on your institutional knowledge. And it might even come back to you and say, your culture sucks. You demotivate your junior developers and you lost 5 of them in the last week or something like that. So I don't know. I mean, it's a very interesting times. As you said, people in academia will have a fun time studying this period in history.
I agree.
I was trained as an engineer in an academic environment. And part of that education, I was trained to work with, let's put it, I don't know the term, college people who are more technical skilled, not academic thinking, but trained to write code or to make devices, physical devices. And so I'm trained to work with them together and together come to the best solution. So without my academic thinking, taking a broad view and not go for the direct obvious solution, things would probably go havoc. That's why I'm needed in a team. So I hear you talk about junior and senior developers, but those people will never be academics, those people who did this college degree. they will not have this, they don't have the skills to look around as much as I do, but they're really more focused. So together we can get somewhere. So I'm sort of confused when you talk about junior. Is that junior from university or with the academic view, or junior from the perspective of a college programmer or whatever, designer or producer? So maybe, and then I'm taking it one step further, I'm trained to work with agents without knowing, and now I can just, these college degrees are not needed anymore. We just only need people with an academic view. Maybe.
So maybe I'll clarify, maybe, or at least my view of junior is basically like doers, like kind of your college people, right? Just go do this, go do this, go do this, right? So these are doers. So in our opinion, the doers are gonna disappear, right? Because the agents can do that, okay? And then now the planners, the thinkers are what's kind of, we believe, are more needed moving forward. Right, is that kind of the views?
So for me, junior is somebody who's new to the project. So I do see what you mean with the difference in that. For me, junior is somebody who's new to the project, so doesn't have any experience inside of that project. It can still be somebody with more experience as a general software developer or software engineer. I think also it's important to realize that we use software developer to envelope also software engineer as a job title a little bit. So we use the term loosely, I think. Yeah.
Okay, but I actually also have a different view that you can have a senior developer who's also a newcomer to a new project, right? But because of the experience they've accumulated in the past projects, they are in a way more senior than, say, a new grad going into a new project, even though they're both newcomers. So I do think that you could be someone who learned, for example, a specific language and design patterns in university and excel on them, but because you lack the experience, you could still be junior, and then you accumulate those skills in the job or on the fly, and you become more senior. So, and your responsibility grow with your role. So in a way, I guess you could view junior and senior as their responsibility breakdown as well.
Yeah, like there's two dimensions. There's newcomer and old timer and fresh. And okay, so we're gonna have to wrap up, okay? Because I think this place is closed at 5. They're gonna kick us out. So I'm gonna ask every one of you to basically tell me one thing you're very excited about and one thing that keeps you worried at night. Okay, about work, okay? So yeah, go ahead. Or who wants to go first? Okay, he has a plan.
So for me, the thing that I'm most excited about is how this real long-term memory is going to be fixed, the way that human memory works, because like, yeah, it's a very interesting challenge technically for me. How is it going to be fixed? Like how you are going to have an agent that works like a human, comes to the job and learns, and after 6 months is expert on everything and knows. So that's the most exciting thing, and that's also the most terrifying thing for me, because we as humans, we live and we memorize things and we sleep, and when we sleep, these memories become compressed, and some bad things happen, some good things happen. We become traumatized and all of that, and so I'm also terrified maybe what happens if the LLMs also become traumatized or something.
For me, the most exciting thing is to see where these agents are going, when we see like full-on apps being developed by agent teams, and how they would impact developers' workflows. And the concern that I have is the gap that I'm seeing it's happening between people who can access these models, these toolings, these agents, and people who don't have cannot easily access these models, and what would be the impact in the long term on people having this access or not?
Okay, so I'm most excited about actually being able to do new things. So there's like very novel ways of testing that we can apply that we could never do. What I'm probably most concerned about is what my OpenAI bill is going to be the next morning when my students go back to work. And also how to teach undergrad students to work with these things, because it's actually very difficult to integrate them into the current way that we have a curriculum. So it's very difficult to mark things around them. It's very difficult to make sure that, like Mehdi said, how we can ensure that they all have access to the same models, because right now students with a lot of money, they use the best models, and if you don't have money, you have to use the free version, right? Which, if you're actually being marked or being evaluated on that becomes a problem as well.
For me, I think the best thing is it's making me productive in different ways. So I can focus on interesting problems. So for example, I haven't programmed in Rust in a long time, but I can contribute to Rust projects without worrying about the syntax much. I know the constructs in Rust, but I don't have the exact syntax in mind, but I can effectively contribute to a project like that. And also, if I want to analyze some data, I can use an agent solution to generate quickly some scripts to verify these solutions. So in various ways, it's making me productive, and I can focus on interesting problems. Even if the model development plateaus, like there's no new models with breakthroughs anymore, the technology that we have will save a lot of time for certain tasks. So as a community, this will be a great thing, even if it doesn't have AGI or ASI or all these things. The technology that we have right now is going to be really, really useful for certain things. So I'm happy about that. What I'm sad about that is like we are sometimes without understanding how this technology is developed. Fundamentally, it's doing token completion, predicting the next token based on whatever past data. But instead of understanding how this technology is developed, we see so many times people are giving it like values it doesn't have, anthropomorphizing, like putting that in some decision-making places. I see a lot of like managers or some big people without understanding the limitations of the technology, using this for certain tasks that it's not suitable because they don't understand this is not really reasoning or doesn't capture human values. It's just doing token prediction. So because of this, a lot of bad things could happen in the future, even if we don't have AGI. So I'm worried about that.
I guess I'm most excited about not being asked a lot from my non-computer science educated friends to write them a script or tool anymore. Because previously it was always, oh, you know how to code, can you help me write this thing? Now they can just ask ChatGPT. So that's the good thing, that everyone can be creative and do their own tooling, and that helps a lot of people that were previously not exposed to engineering. Yeah, I could say that's my nightmare, to fix the vibe-coded code, but yeah, that's one of them. But the other nightmare would be it feels like the whole corpus out there, or the whole data existing in a while, has been so polluted by the generated content, and you can't tell. Well, in a way, you could sense that this is probably not written by human, either natural language or code or any artifacts. In a way, it's all mixed together, and now it's just I don't know if we can call it clean or not, but like it's not. It doesn't. It just, the quality becomes so diverse that I feel like there will be some downstream impact very soon, given the current situation. Yeah.
Good. I don't have to say my stuff. Okay, so I would like to thank you, and thank as well the audience for today's panel. So thank you so much. So I hope anybody learned something out of this. And as I said, so if you're interested in this field, please make sure, you know, we put the what do you call it, the QR code for the Slack as well, and as well there's the AIware conference later this year. Okay, so if you're interested in that, please, you know, participate in this community, and I hope you learn one or two good things, and you're worried about one thing and happy one thing. Okay.